Hello guys, welcome to join our session to revise for the quiz 1 in quarter 4. Okay, which is talking about the increasing and decreasing function and the first derivative test. Here, let's begin with the first question, which is which of the following statement is true of fx, which equal negative x to power 3 plus 9x squared minus 24x plus 18. As you see here, all of the given is talking about what? Increasing, decreasing, is increasing on which interval? All of the given, the interval in which a function is increasing or decreasing. Since we ask about the increasing and find the interval in which a function increase or decrease, we use the first derivative test. Okay, here increasing or decreasing, we use what? First derivative test. Let's show you what is the first step. Wait a minute, I need enough space. Use the first derivative test. Here, what is our steps? Step number 1. First derivative, which is here negative 3x to power 2 plus 18x minus 24. We said that is the first step, find the derivative. Then find the critical number. What is the meaning of critical number? The values of x at which the first derivative equals 0 or does not exist. Second step, by setting what the value of the first derivative equal what? 0 plus 18x minus 24 equal what? 0. By factorizing implies take what? 3 as a common factor. Negative 3. Take negative 3. So it will be x squared minus 6x plus 8. Then equal what? 0. Implies, please continue factorizing. Okay, here also negative 3. Here x minus 4. X minus 2 equals 0. You can use from the beginning the calculator mode 5 3 and you can find. Okay, the zeros come from this brackets. This means x equal 4 or x equal what? 2. That is our critical number. Maybe, no, but I'm not talking about extreme. Then, what is the third step? Use the first derivative test. When we talk about increasing, decreasing, I use first derivative. But concavity, as in worksheet 8, don't confuse between both of them. Use the second. Here, first derivative. Okay, write the critical number on the line from the smallest to the greatest, 2, and here what? 4. As you see, the critical number divide the domain of the function into 3 interval, 1, 2, 3. Okay, the next step, state value, which tell me, the test value, I use it to substitute in the first derivative to tell me the sign of the first derivative. Positive, in the function increasing. Negative, the function decreasing. Okay, here we choose 1, and here I choose 3, here I choose 5. Okay, then replace in what? That is first derivative. Okay, replace in the first derivative. Using what? The calculator. If we take 1, it will be negative 27, negative, it will be negative. The first derivative negative. Use the calculator. I don't care about the value, but I care about the sign. Less than 0, it means what? Decrease. Function is what? Is decreasing. Here negative infinity, and here what? Infinity. 3, here it will be what? 27, negative, yeah, it will be negative. Okay, less than 0, it will be negative or positive. Here 1 negative. Wait a minute, I calculate. Just 1 minute. Give me. No, I'm sorry. It will be 3. The result, it will be 3 positive. So it will be what? Increasing. If you replace by 5 here, it will be, if derivative, it will be less than 0, it will be decrease. So which one here, the function is in decreasing on negative infinity, 2, 4, and infinity, but increase here. Here decrease, here increase, here what? Decrease. So if is decreasing on 2 and the open interval 2 and 4, no, it is increasing. The first one is wrong. If is increasing on 3 and infinity, I don't have critical number 3 here. 3 and infinity, no, wrong, because here increasing only into infinity. B is wrong. F is increasing on 2 and 4, that is the right choice. That is what? The right choice. That is why your correct answer is C. I hope you understand. Since the given here is talking about the interval in which a function increase or decrease, I use the first derivative test. Please revise all of the videos which I posted already before. Okay, I think it's easy. Now, look, I rub this one. Do you know why? Our result is what? C. Let's solve this one from the graph. It's so trivial. Here, use the graph to identify the open intervals on which the function is increasing or decreasing. I think it's so trivial. Here, I have 2 intervals. That is what? Negative infinity. That is what? Infinity. Here, what? 2. At 2, x equal what? 2. Here, 2. To divide the domain, which is here, as you see, into 2 intervals, negative infinity 2 and 2 infinity. Here, as x increase, y what? Decrease. As x goes right, y goes down. So here the function is what? Decrease. By the same way, here as x increase, y what? Decrease. Here the function is what? Decrease. Here the function is decreasing on both interval, negative infinity and 2, and the other interval, the open interval 2 and infinity. It's so easy. And at 2 here, it is not, here the derivative what? Does not exist. The first derivative does not exist. It has what? Disjoint. Here there is discontinuous. Okay, so it is what? Decreasing. What is the meaning of decreasing? As x increase, y decrease. Or by another way, as x goes to right, y goes down. I think you remember now. Okay, do you know why it is decreasing on this one? Just by looking at the graph, because I don't have the rule of the function to use the first derivative test. Okay, now this problem, it's so easy. But I'll show you how to use it as in set. I don't need to do all of the steps to find the relative maximum or relative minimum, or I'll show you. Let's begin this question here. Given this function, as you see, okay, it is a given, has a relative maximum. Relative maximum, like this one. What is the mean relative maximum? Function before it increase, then what? Decrease. That is the relative what? Maximum. Here increased and here what? Decreased. Okay? At x equal what? 6. If I draw like this one, I don't need to do anything, just draw the line. Focus with me. At x equals 6, here, that is the critical number. Here negative infinity and here what? Infinity. Focus with me. I don't need to do anything, just interpret the given. Relative maximum, it means like this one, increase to reach it to the relative maximum, then decrease again. Okay, this means the function before 6 is what? Increased, and here what? Decrease. As you know, if the function increasing, the first derivative what? Is positive. If the function decreases, the first derivative is what? Less than 0. Here positive, and here what? Negative. Clear or not clear? This means he asked me about the sign of the first derivative. positive or negative. Do you remember these things or no? As we did before in the first derivative test. Relative maximum, this means the behavior. Look, as you see here, just draw the line and put that is critical number at which we have an extrema. Okay, as I do, I don't need more than this. Here, the first derivative is positive on the interval 6 and infinity. 6 and infinity in this interval, it is negative. You have this one wrong. The first derivative on the interval negative infinity to infinity is positive. No, it's wrong, because sometimes it is positive, sometimes it is what? Negative. First derivative is negative on interval 6 and infinity. 6 and infinity is what? Negative. This one, that is our choice, is what? Part C. I hope you understand. Like this kind of problem, maybe you will have in the exam. Just draw the number line and put the critical number on it, which divide the interval into the domain into two intervals. That is interval 1, that is interval what? 2. Relative maximum here, it means the function, it changes its behavior from increase to what? Decrease. From increase to relative maximum, it means the function before this critical number, its behavior increasing until reached to the maximum. That is called what? Maximum. Okay? Then become to decrease again. As you know, if the behavior of the function is increasing, so the first derivative is positive because its tangent is what? The slope of the tangent is positive. Understand or no? I hope you revised all of the videos before begin see this revision. Okay? That's all. And in the exam, you will have a question like this one. Don't solve it by using the first derivative test. No. He helped me to give me the critical number. He gave me what? The critical number. And he tell me it is a relative maximum. Only I have to know what is the meaning of relative maximum, the behavior of the function before it what and after it what. Like this problem you will have in the quiz. Okay? Here, let's solve this one. Use the first derivative. He asked me, look here, use what? The first derivative test to investigate fx equal x to the power 3 plus x for relative extrema. I want to know the relative extrema occur where? What is the meaning relative extrema? Maximum or minimum? I'll show you. Now, what is the first step? This means I have to follow the steps. But the others one, he give me relative. He tell me what is the relative. Okay? The first derivative, x here, it will be what? Plus 1. What is the second? Here, clear or not clear? That is the first derivative. I want to find the okay, that is the first step. Second step, equate or set the first derivative equal what? 0. To find the critical number, because the extrema occurs at critical number. If we don't have critical number, we don't have extrema. Okay? Here, 3x squared equal negative 1 implies x squared equal negative third. It is impossible squared value equal negative value. Impossible to have a squared value equal negative value. This impossible. Okay, in this case, impossible, in this case, since there is no critical number. No critical number. If we don't have critical number, no relative extrema. If you don't, because you know relative extrema occurs at critical number. Since I don't have critical number, we have relative extrema. Okay, because what is the meaning of relative extrema? We have a critical number at which the behavior of the function changes from increasing to decreasing or decreasing to increasing. Since I don't have the first condition, I don't have the others one. Here, that is why your answer, it will be F has no relative extrema. I think it's so trivial. Okay? Now, for the others one, use the first derivative test to find the x values that give relative extrema. Here he asked about x value. He didn't say point. Here he asked what? X value. He didn't say point, x and y. Okay, how to see this one, how to solve this one, I'll show you here. I have to use the first derivative test. It means, first derivative, it will be what? Negative 4x to power 3 plus 6x squared. That is the first step. Second step, find the zero. Set the value of the first derivative equal what? 0. Then factorize, take what? 2, x to power 2 as a common factor, or take the negative. I like to take the negative. It will be x minus 3 equal what? 0. Okay, I think, okay, this one is okay. X square, yes, x equal. There is something wrong, I think. Yes, here too. I saw there is something wrong too. Okay, here, so critical number at what? X equals 0 or x equal what? 3 over 2. Third step, draw the line for the first test. That is the first derivative what? Test. Here, write 0. Here what? 3 over 2. Test value, test value here negative 1. Here between 0 and 1.5 I will take 1. After 1.5 it will be 2. Then replace in the first derivative. In what? First derivative. Because I use first derivative test. Where is the first derivative? Here. Okay, just replace. Okay, negative 1, it will be here negative 4, positive 4. Then it will be positive. Just by replace. I calculated mentally, but use your calculator. Okay, positive. Here, by replacing 1, it will be positive. Also positive. Okay, the first derivative is a positive. At 2, it will be 8, negative 32 plus 24, it will be negative. Less than 0, yeah, it means negative. Positive, it means increase. Here, increase. Negative, it means decrease at the theorem. Look here, at the critical number 0, the behavior of the function does not change. It's still the same. Increasing, increasing. So at 0, we don't have any extrema. Here, no extrema. But at 3 over 2, the behavior of the function changes from, look here, changes from what? Increase to what? Sorry, to decrease. So it will be what? Relative maximum at 3 over 2. This means, okay, here at x equals 3 over 2, f has what? Relative maximum. Understand or no? I hope you understand well. That is your result. Do you know why at x equals 0, the critical number x equals 0, it is not a relative, it is what? Not a relative extrema, because the behavior of the function does not change. Okay? I hope you understand well. Please revise. The behavior of the function increasing or decreasing depend on the sign of the first derivative. That is why we use the first derivative test. Okay? Okay, now let's see how to solve question number 6. Here I give you function fx equal x plus 2 all to power 3 minus 4. The point negative 2 and negative 4, the point, this is point, not interval, is absolute maximum, absolute minimum, okay, a critical point but not an extrema, no critical point, none of these. Since we are talking about extrema, critical number, I have to find the first derivative, okay? I have to use the first what? Derivative test. Here, all of the question, as you see, use the first derivative test. The first derivative for x, it will be general power rule, power 3 multiply x plus 2 all to power 2, okay? Then put equals 0, 3x plus 2 all to power 2 equals 0 implies this bracket equals 0. The 0 will come from the inside the bracket x plus 2 equal 0, x equal what? Negative 2, okay? Use the first derivative test at negative 2. Here negative infinity and here what? Infinity, okay? Before it negative 3, okay, test the value at its left on the number line, at its right on the number line. I'll test what value? Negative 1. Just replace in the first derivative. I give you the steps, but I tell you another way. One of you can solve it mentally. One of you can solve it mentally. From step 1, I will not continue, but I'll show you now. Here it will be what? If you replace, it means greater than 0 increasing. Okay, if you replace also, it will be what? Greater than 0, it will be what? Increasing. So in this case, at negative 2, it is a critical number because it is the value of x at which the first derivative equal what? 0. But the behavior of the function does not change because around negative x equal negative 2, the behavior of the function is still the same, increasing. So it is what? Critical number, but not an extrema. Critical number because the first derivative, the value of x at which the first derivative equals 0. But since the behavior of the function does not change, it will not be. That is why we choose part C. Just since by looking at the given answer here is talk about critical number extrema. So I have to use the first derivative test. And why you use the first derivative test? You don't use the table because he didn't give me closed interval. Okay, first to find the relative extrema on for a function on an open interval, I use the first derivative test. Okay, now look with me about this question number 7. I solved it. I think it is repeated. That is why I will not solve it again. I will not what? Solve it again. Okay, I'll make a second part to solve this question. Thank you for joining.